All right. Welcome everyone. Like Dan said, I'm Tyler Sturts. I'm the platform integration manager on the strategic accounts team. So I'm gonna be we're gonna talk through lots of HTTP and JSON stuff today. So we'll go through some of the HTTP commands, and we'll go through some activities around those. So we'll start with download, and go through how that works, and then we'll do some fun stuff with some parsing of some JSON strings, and then we'll go through the upload commands as well here. So to start off, I'm just gonna open up the download here, and we'll just take a look at kind of what this looks like. We're not gonna do anything with this, but we're going to just take a look at kind of what the structure of the code looks like. So with the download command, we have our download command down here, and then all of the properties are built into a table with that command. So you can see here, we start our table. Our first entry is the URL that we're accessing. So here we're going to go out to Google, and then headers. This is very dependent on what you're talking to. So with this one, we're just going to parse the information back as JSON. So we're going to call out content type. Uh, the best tool that I would say to use for this is there's a tool called Postman. Works really, really well. And you're able to just trial and error the headers. Unless you have a documented API, headers is basically a guessing game most of the time. So trying to get that to work, Postman's a very good tool for that. Timeout is our next entry. Just how long do we wait to timeout? So we're going to wait 30 seconds. Nothing happens. It'll shut that down. And then the event handler is what happens when the download has finished. And then done is just a variable. So it could be called anything you want. It could be called, finished. As long as this function up here that we're going to call in a minute is labeled the same, that's what's going to get called. So then in our return function up here at the top, we have done, and then we have some information inside of there. So it's going to pass in a table of everything. It's then going to specifically pass in the code. So that's your success or error code that's going to come through. So you're probably used to seeing, 404, errors, or a 200 success code, 202, just depending on what you're talking to. And that's all documented in the HTTP protocol. We have that on our website, and I can show you how to get there in a second here. But then the next section is going to be data. So this is all the information that we pulled down from google.com. So if we were to do this, we'd get a ton of information. You'll see us, we'll do that here in just a little bit. Errors. So these are any errors that come back, and then headers are anything that Google is sending back to us. And then we're going to, right here in this next is just printing it out. So we're using string.format to format our response. So this is how we're going to format this. So we're going to, show our response, our return code, and our error. And how we're doing that is I'm going to go into this table here. We're going to grab the URL out, and we're going to put it in right here as our first entry as a serial string. And then our code, which is right here, which we passed in from here, is going to be an integer. So like I said, that's going to be your 200, your 404, your 202, just depending on what you're talking to. And then any errors that come through will be printed here. And you can evaluate errors. So what we're doing here is we're saying if there is an error, put it here. If there is no errors, then print none and put it next to errors. So we can evaluate against one of these as well in this format here. Now, if you want to see all the different headers is also a table. So we can print this, and then what this logic right here is doing is just running a pairs loop on that headers table. So we're able to print out the name and the value, and then just go through it until it's printed everything inside that table. And then this will print out all of the data here inside of what has been downloaded from the google.com site here. So let's go ahead and let's look at how that would work in a functional script. So I'm going to jump down here into our HTTP GET. And you'll see here, we just have a download button. So if we open this script up, we have a blank section. So what I'm going to do to save time is I'm just going to grab all of this and let's throw it in here. And if there's any questions along the way, feel free to pop them in the chat. And Dan can interrupt me. We can get through that. So what we just did here is I just copied everything we just did. So this is going to go out to google.com. It's going to wait 30 seconds. If it doesn't get a response, it's going to kill it. So let's go ahead and let's save this. And let's go ahead and emulate. Something else is emulating. All right. All right, there we go. So this is what happens when you download the google.com website. You can see just tons and tons of really good information that you could use for your AV projects going forward. Obviously not. This is not something you would want to do. Functionally, this is just an example. But you can see here, let's kind of split screen these so you can see the information. So you can see here our print string is right here. So it's HTTP response from google.com, which was the URL we pulled out of this table. Our return code was a success code of 200. That was pulled right here. And then errors, there were no errors. And so we printed none in that response. And then you can see here HTML data. So we returned the line so that we got to a clean break. We printed HTML data and then we printed everything in this big, huge section. So this is everything about google.com's webpage. So that's kind of the basis of how the download command works. Let's go ahead and let's jump into actually using this. So I'm gonna just, I can leave that. I'm gonna comment this out just so it's not doing all of that over and over again as I emulate and stop. So let's go ahead and disconnect here. And let's go to our next section here. So what we're going to do here is, let's open this up so we can kind of see what's going on. So we have a whole bunch of information here that we're going to download a table from our web services center that we can pull all this information in and then we can parse out individual pieces of it. So we're going to use the same commands that we did for here, but we're going to talk to a different site. So you can see we get core model, IO, all this other stuff. So let's go ahead and open this up and you'll be able to see.
Did we have a method for sharing this, or was it in the assets that go out ahead of time? Maybe it wasn't.
No, it goes out. I don't think they put it in beforehand. They have it
I don't think
when
so.
I've done this before.
Yeah, I just have
The
a
finished
question.
files will get out.
Yeah, you'll get a copy of the recording and you'll get a copy of this file after the
Correct.
fact, Domingo. So
Yep.
yeah, we may consider loading it on the front side too. That's not bad.
I
for
think that's a good
following.
idea.
So
Yeah, because then people can follow along if they want to.
so
Yep.
sorry about that, but yeah, be good.
All right. So what we have here is we have kind of the basis of our script that we're going to start writing. So you can see we have a URL right here that we're able to get this JSON file out of this. So what we can do is we can, let's write our get command. So that's going to be down here. And just like before, I'm just going to go over here and grab this logic out so I don't have to type over and over again. So we're going to go down here into our get, and we're going to write in our get function here. So this is our download. So URL is going to equal google.com, but that's not true. So let's go up here and let's grab, we have our variable URL already, so we can just replace google.com with URL. And then our content type will be application JSON. And then we also need to accept a specific or everything that's coming from this. So we can do except. This can be equals. And then the way to accept all is just star backslash star. So that's going to accept every piece of information coming from here. And then we then call our event handler, which is labeled done, which makes it easy because then we can just go grab this guy. So now we've gone through and downloaded our information from our website up here, and then we're passing it through back up to our return function, and we're able to print that statement out, and then we're going to print all of the data that's coming with it. But for this, the sake of this, we're not actually going to print the HTML data for this because we don't need it in that format. We're just going to download it and make sure that we got everything that we needed to here. So we can go ahead and let's run this just to make sure we're talking to the site. So you can see here, we got this, we returned it, and the error was none. But we're not doing anything with the data yet. So we're able to verify that we're talking to it correctly and everything succeeded appropriately. But now let's go ahead and do something with this data. So the first thing that we want to do is let's go ahead and let's define in the tables that we'll be encoding our data into. And so we're going to start with our cores list. So we have a list of cores. And so we'll just generate a table, a blank table for that, that will pop all of the information from our JSON file into.
Can you zoom in a few clicks,
Oh,
please?
yes.
Thank you.
I always forget that part. And then we're going to then cores is the name of our JSON, so that's all the information. And then we're going to build a list of just the cores off of there. So I'm going to call that core list. So the one thing I did skip over, let's talk about this because this is very important. So when you're dealing with JSON, this is not very big JSON file. But if you're dealing with large amounts of JSON inside of a file, using the rapid JSON library is imperative. Otherwise, you could kill the Lua processing in there just from how much information it's got to parse through and pass through. So requiring the rapid JSON library here is a necessary step here so that we can go through and parse that JSON appropriately in a timely fashion versus using just the standard JSON library. So first thing we're going to do is let's come down here. So we know that we got our data and our data is the JSON file. So let's go ahead and let's set our cores table and we're going to decode that JSON coming in. So we're going to do JSON, which is the variable we defined up there, dot decode. And what we're decoding is our data coming in from that connection. And now, what's inside of that JSON, obviously you could download this file, look through it. I know what we're looking through, so I'm gonna kind of jump through here. We can look at this JSON file in a little bit inside of, we'll pull it up in a VS Code here and take a look at it. So what we're gonna do is we're gonna jump through this table now. So it was a JSON string. We decoded it now into a Lua table. And so what we're able to do then is run through it. So we're going to do for key value, and then we'll use our ipairs loop. And what we want to run that on is cores. And inside of each one of those, there's a core list. So there's a list of the MB32, the 510, the 110, all the way down. So I'm going to jump into that table and grab out the core. And then what we're going to do is we're going to insert that into the other table. So we're going to use table.insert. And we're going to insert that into the core list table. And we're going to use ctl.name, or sorry, not ctl, v,
I've got a question
v.name.
here, Tyler.
Yeah.
Um, this is from Tyler Store, and he says it's a dumb question, but really the question you don't ask is a dumb question. But what is the use case for running iPairs versus pairs?
Oh yeah. So I pairs versus pairs. So I pairs is iterative pairs, meaning that there is no key to each one, or the key is a integer. So meaning that the first entry in the table is 1 equals, let's say blue, 2 equals yellow, 3 equals green. In a pairs loop, the key would have an actual value. So it could be like banana equals yellow, orange equals orange, and apple equals green. So that's kind of the difference between iPairs and pairs, is being able to assess specific keys to a value versus just an integer number to a value.
Reminds me of something I heard the other day that says um, grape soda tastes nothing like grapes, but it does taste like purple. So that's all I'm adding to this webinar, guys. Sorry.
Just just great banter. Yes.
When you said orange equals orange, it made me think
Yeah. Well, that's why I started with orange. And I was like, nah, that was a bad example, but uh all right, so now that we have all of our names in our core list table here, now what we can do is we're going to assign them to, let's close this. We're going to assign them to our list box right here. So if we go back to here, we can access our controls and then our core model. And the way we add in items to a list box is use the dot choices metadata. And now we can just add in core list. So if we go ahead and emulate this, I don't know why I stopped emulating, because we could do all this live. But you can see here, now we get all of the names of the cores in our list here. But you'll notice once we click on these, they don't do anything yet. So what we want them to do is when we click on this, we want to populate the IO, the AEC, the VoIP, and the USB IO bridge with information about each one of these. So let's go ahead and do that. So you can see we already have some stuff here ready to go. So what this does is this clears out all of that information on the startup of the script, so that it can go grab anything new that maybe has come in for that. So what we want to do is we want to parse our core details. First thing we're going to do is we're going to create an event handler. So whenever that list change, we want to do something. So we're going to do controls dot core model, and then this will be the event handler off of that core model. And we'll define a function and pass in control and end it. Please end all of your functions when you start them, unless you like getting lost later, especially when you get bigger and bigger scripts that get more and more complicated. So let's run a loop on our cores.core. So we're gonna do for key value in iPairs, and then we're gonna run that on cores.core. So anytime that core changes, we're going to go through and grab information out of our JSON file. If I can type. And then the first thing we want to know is we want to know if the value of this equals the string in this core model. So we can do if v dot string is equal to, oh, hold on. Oh yeah, okay. No, I was right. I just second guessed myself. Is equal to ctl.string. So ctl.string is basically we're passing in the control of this right here. So this replaces this equals CTL. So we can pass that down here. We can say, hey, when this changes, if the string of this equals one of the strings inside of our cores.core, then we can do something with that information. So let's go ahead, press that. So now that we know they equal, now we can go through and we can grab all the information out of that JSON table. So our first thing we're going to do is we're going to go to our network IO. And that one is a string. And now that we have done this, run this iPairs loop on here, we know v.string can be our, or v is equal to our entry in the table. So it's our 110, it's our 510, it's whatever it may be there. So we can actually dive into that table a little bit further. So we know it's v, but now we want to get inside there so we can actually call out network IO. So that's going to go in and grab the network IO out of that table for this specific core that we've called out. And then we could keep going here and we will grab our next one's AEC channels. That one's also a string. And then this is b dot number AEC. So in here, number AEC looks like that. Before I get too far, I should have talked about this JSON file before so we can actually see it. Obviously, you're never going to just do this blind. Let's open up. Should have this open so you can see it. Clients. Train.
Man, you have nice organization skills there. Can you come organize my files on my computer?
If I don't organize them, I'll lose everything on my computer because
Oh,
I'll
I'm with
never
you.
know what anything is.
And it seems
So
to make sense to our brains, right?
yeah, right. Yeah, it probably doesn't make sense.
I do have a quick question here. Are there any resources for learning this process for much larger JSON tables, saying 2,000 or so entries? I don't want to iterate that entire list every time. I need a piece of data. And I'm unaware that a lookup table is likely I am aware that a lookup table is likely the answer, but I'm wondering if there's a resource for learning more tools like that.
We don't internally have anything for parsing large amounts of JSON data. I mean, obviously, yes, a lookup table would be the correct way to go about parsing through that. I would say there are plenty of websites out there that teach. Udemy is a really good one that has a whole bunch of classes on Lua and those type of things. We talk
Spell
about, we
that?
have a Udemy, I think. Udemy. Yeah.
All right.
So that it's just kind of like those are self-paced classes that you can look up different topics. Like I've taken a Lua one, I've taken a CSS one. There's some for, prep courses for different certifications and stuff like that out there. The other one that I don't think we go through it in detail, but we do reference lookup tables is the control quick start on JSON that Jeff Perkins has done. There's some information in there about it, but I don't think it dives super deep into there. It's just more, it's a little more in depth than this webinar is, but it's not, I don't think, to the level that you're probably looking for.
Yeah, in the chat, we just had someone send us about the website spelling, so it should be
Okay,
as well too. Cool.
perfect.
All right.
All right. So, inside, I'm just looking at the JSON file that we would have downloaded, that we downloaded from the AWS site here. But if you look at it, so cores was the name of the table that we created, and we parsed this whole thing into that cores table. So calling cores.core, what that does is it dives into this level, and now we can get to each of these entries. And you can see the name is here, the network IO is here, AEC is here. So we can actually go through and do all of that all that parsing into that table there. And that's how we're able to replicate this. Now inside of VS Code, there's things called extensions. So one of them that I have downloaded that I really like is called JSON crack. So this one helps with your larger amounts of data. Obviously, this one's pretty easy to jump through. You can get into some pretty pretty crazy JSON strings that have just massive amounts of, throughs and stuff like that. So what we can see here though is core, which is right here, is the head of the table. And then we have entries inside that table with information in there. So this is a really nice way to visualize JSON. Obviously, if you get to, I don't remember what the limit is of JSON crack, but there is a limit. I've reached it before many times. And there's some tools online you can use similar to this that's able to kind of decode the JSON easier for you to visualize it this way. So, all right, so let's jump back over here. So we're able to pull out our AEC channels. So our next one's going to be our controls dot. This will be VoIP instances. This one's also a string. And I'm going to show you a quick, easy way that we're able to, or not quick, easy, I'm sorry, a different way that we're able to grab this. So cores.core is going to be equal to V here. So what we're doing is we're just shorthanding this because we're able to return this each time. Now, if we weren't doing it that way, we could do it a different way. So we could call out our cores table. We could say core, and now whichever entry inside of that table, so first, second, third, fourth entry, we know what that is because we have a value here because we're running in iPairs. This K is going to be equal to that value. So we could do cores.core K, and then we could say number VoIP is what that entry in the table is. And we could see that here, number VoIP right here. So let's go ahead. We could do that again here for our last entry. So this is going to be, and this one is not a string. This one is just a true false statement. So we're going to access the Boolean, and let's do the same thing again. Cores.core. Okay. And this one is USB bridge. Just like that. And then once we're done with that, then we'll break our loop because we know that we found everything we need. And now we can save that. So we're almost done with everything. The last thing we need to do is on startup of the script. Let's go ahead and set our choices to our cores list. And then the only other thing we need to do is right now, we want to call out our function. What did I do? Oh, gotcha. So this is just going to run the first time. If we wanted to make this repeatable, we could call this function download. And now we can call this over and over again based off of, an event handler firing or whatever we might need to do. And then to get this to fire on the script start, we can just call out download down here at the bottom. So you can see now I did something wrong. Perfect. I do this on purpose so we can troubleshoot together.
Should it be dot string, be dot name? And I'm pulling that out of the questions. That's not me.
Say that again.
We've got a question, or in the question section, should it be dot string? Should dot string be
Yes.
dot name?
Thank you. Very good. See, Did that on purpose so you could all follow along with me.
Perfect. See, I'm
There
glad
we go.
everybody's paying attention. Nice work.
Yeah, yeah, perfect. There you go. So now you can see as we progress through each one, you can see our IO channels change, and you can see how many AEC channels each one has, and our VoIP change, and then based off of if that core supports USB or not. So you can see obviously the bigger cores don't have a USB bridge on them, but everything down from the 110.
Like I always say, LEDs aren't just pretty, they're logic highs and lows.
That's how you get them to flash, right?
Oh, there you go.
Ooh, yeah. All right. So we're going to do one more section here on our REST API. So now we're going to talk to a specific piece of equipment. So I have, just pull this over here so you can see it. I have a Pi here running Falcon Player, which is a lighting control platform. So we're able to grab some playlists and do some things. But what we're going to do first is we're going to talk to it and get we want to get a list of these playlists right here that are all in here. So cloud running and spotlights. And so we have some API documentation here so you can see they nicely let us have what the headers are, so it knows that we need to accept all, and then we need to reference the host IP inside of here. And then we have our get command here, and then this is the output in which the get command will return the playlist in. So, and then our commands right here are API/playlists. So what we could do is let's jump over to this guy and let's go ahead and talk to our Falcon player here. So first thing we need to do is we need to grab our HTTP commands again. So we need our call function and our download. So let's grab this, jump over here. So we have our download command. Our first one is going to be the URL. And so the URL that IP is this IP right here, there. Okay, there we go. So this is the IP that we're going, but we know that
Zoom back in
inside,
again.
yep, thank you.
There we go. Thank
Kind of
you.
like a auto zoom in mode. See, the URL is here, but we know that in our API documentation, we needed /API/playlist. So let's go ahead and add that API/playlist. So we have now our URL, our headers are accept, so accept. And then our other one that we needed was our host. So we need to call out the host. And our host is this IP. Cool. And then our timeout and our event handler. So what we could do here is now we know that we're getting our information back here. So we'll print our confirmation string. And what we're going to do is let's go ahead and let's print out our data. So we're gonna and call it data. Return data right there. So we can see what data is. So you can see here, down here at the bottom, our data is cloud lights, running lights, and spotlights. So that's our JSON string that we got back. Obviously a lot less information than the last one. So what we can do is we can just set it equal to table playlist, and we'll just do JSON dot decode of data. And then we know from our previous one that the way we set the names is dot choices, and we can do table underscore playlist. So now that we got that, we can come back over here. And now you can see we have cloud lights, running lights, and spotlights. So we got all three of our entries in our playlist right here. And we're sending those out here, which we will get to here in a minute. And use that to do some commands here. So now our next step here is we're going to talk about upload. So let's jump here. So very similar to download, minus a few things. So with upload, we have the same kind of concept. So function upload, which is a table. And then we have some entries inside of our table. So we have the URL that we're talking to, the method. So depending on what you're talking to, this could be post or put, just depending on how the device you're talking to wants to see that command. If you need authentication, this is where your user and password would go in. And then this is any of the data or the data that you are wanting to send out to your device. And
Zoom in
then
again.
any headers. You'd think I'd have remembered that eventually, but I guess
It's all
not.
right. We need like a remote camera control, but remote zoom control.
There you go. Yeah. Uh, and then this is the headers table inside of the other table. So this is any headers that are required to be sent out to there. So this authentication, this is where it would be basic or digest authentication. And then our event handler fires up here, and then we return our table, our code, our data, and our errors here as well. So in what I'm going to do is there's a section in here that really, in my opinion, doesn't really help us too much. I'll show you what it looks like, but this is just something you can play with later. There's a day or a what they call a toilet. So it's a post test server, and you can create a toilet and you can upload or dump information into it, and you can see that come through. So it's kind of a cool little tool if you just need something to test against and you want to play with some HTTP upload commands. You can do that here, and this will be included in the file. And I did update it. There was a post test server 2 that got spammed so much that it got taken down. So there's a new one for post test server 3, and you can upload commands or data and send them over to that. So, all right, so let's get to our last section here. And you can see that up here, we're already changing which playlist entry is coming down to here. Because what we're going to do is let's look through this here. So you can see that we are going to send a command out, and we are going to use a get command. And what this is going to do is we can actually send information out to our Falcon player to start the playlist with specific things. So you can see we have some arguments of the playlist name, if we want to repeat it, and then if not, running. And then we also have a command here on how we stop the commands. And our headers are right here. So this is our content length, our host, and our excuse me, and our content type. So we can go through and write this out here. So Let's go grab this, open this up. And now what we're going to do is we're going to pass that string in, and then we're able to then come down and access which string has been passed in, and then we can hit play or stop depending on which string that is. So we know that we need our upload. So let's go ahead and grab our upload out of here. So first thing that we're going to do is we're going to upload our information. So I'm actually going to change this to say post data. So that's going to be our function. And we're going to actually pass in our JSON data to here. So we're going to call that JSON data. And then we have our upload, and now our URL, which we need to go grab. Let's get some of these out of the way. Here we go. So we know that it's API and command, and then our command name. So what we're actually going to do is the command name is our argument. So we're actually going to just stick with API command, and we'll pass in that command name later on here. So our URL is going to be our IP address, 47.
Be great if I could read that.
Oh my gosh, it would, wouldn't it? It'd be so cool.
I'm trying to get it before it comes into the question queue.
Yeah. All right. So, and then let's add in our API and our command. So this is our URL that we're going to send out each time. Our method for this device is post. We do not have a username or a password, so we don't need to worry about those. And then our data is going to be our JSON data that we passed in. Get rid of that. And then our headers, the first one's going to be content type. It's out of here. Except this one is going to be application JSON. And then we have our content length. And we're going to use a shortcut here. So JSON data. What this is this is going to evaluate JSON data for its length and pass it in right here. So that's what the pound key is for. And then the last one is our host. Cool. All right. So, and then we have our event handler that's going to fire when that's done. So then what we can do is we'll just come up here, and we don't really need to do anything with the data, so we can just leave this return function alone. But we do need to come down here and create some, just get rid of that. We come down here and create our event handler off of our play and our stop buttons. So our first one that we want to do is let's do controls dot play dot event handler. And let's pass in our function. I don't need the control. And then what we're going to do is we're going to make a local table, and we're going to build out our play command. So let's go ahead and table underscore command. So we have our command, and then let's build our table. So if we remember that in our documentation, how the formatting is our first one is going to be command start playlist. So we're going to do command equals start playlist. That's our first entry. And our second entry is our arguments. So that's down here. So args. And then our. So our first argument is going to be the playlist name. So it's going to be controls dot playlist dot string. And then we're just gonna set the next two to false because we don't want to repeat it and we don't need to do anything with the if not running here. So now that we have our local table command, what we can do with that then is we can, let's just go ahead and print it so we can see it. So it'd be JSON dot. Now, instead of decoding it, we are going to encode this because we're turning it back. We're taking it from a table into a JSON string. And then we're going to print table command. And now, since that's finished, kind of. Oh, probably and the other two. There we go. So now that that's finished, now we can post our data. So we can call in our function up here. So that's our post data function. And what we're going to pass in is our JSON data that goes in here. And we know that that is right here. So we can actually take all of this because we want it needs to be encoded in JSON and do it just like that. What did I mess up? Oh, that's where that last curly bracket went. So now we've built all of that here so that we can send our play command. And now we just need to do the same thing again, but for our stop command. So we're going to stop it. And then if you remember over here, our command for this is just stop now with a blank arguments table. So if we come back over here, so our command here is just going to be stop now, and then our argument table, empty arguments table. And now we can do the same thing again. So we can use this because this is a local variable, it's inside of this function. We can use table command again because they're both local to the function. They're not global variables. So now we have all of that done. So let's go ahead and see if we can get this to work. So we should be able to choose cloud lights, which would go here. Let me side by side these so you can see. So you can see cloud lights. I can hit play. You can see cloud lights is going. It's playing. And then I stop it. And then we can go running lights. Changes. It's playing there. And then spotlights. There. So you can see how we grabbed a list of information from here, returned it to this table, and then we can use that selection to then play or stop those specific playlists. Cool. All right. Got 7 minutes left for all of your questions.
That's good. Man, even with my interruptions.
Yeah.
And we started
Yeah.
with 59 and ended with 69. So we've had some folks join even.
There we go. I'm trying to figure out I get my little menu back. It's somewhere. So did we get all the questions answered?
Yeah, I think so. We were dealing with them as we went along, which is the best way. And if nobody has anything else, Tyler's added 6 minutes to your days.
Yeah, absolutely. But yeah, we'll be here So if anyone has any questions, feel free to pop them into the Q&A. If not, thank you everyone for joining.
Oh, there's one. This has been great. Thank you, Jeff says, right on.
Thanks, Jeff. Where can I find the recording? So the recording and this designer file will be sent out as a follow-up to this webinar, usually sometime the end of this week or beginning of next week.
Yeah. So that's, yeah, this will be, you'll get an email in the next few days. We've actually recently added a person to that team. So it used to be within the next week or two, but it's usually within a few days you'll get it. So.
Yep.
Much appreciated is in here. Thank you. Very cool. Thank you. All right. Heard some boom. Wow. Warapong. Where are you calling in from? Wow, that's awesome. That's a unique. It is pretty interesting that globally people will join this too, because we don't prevent anyone from doing it. So
yeah,
kind of awesome. Well, right on. I got all of our greetings and salutations out of the way. If there's no other, we'll hang for a few.
Yeah. Turns out you shouldn't hide that bar because I don't think you can get it back, or I'm just not looking for it. So
You're gonna have to rely on me. Oh, to stop sharing.
yeah, I just don't know how to stop sharing.
Oh, here we go. You're viewing his screen. View options. Stop participants sharing. There we
There
go.
we go. Okay.
Nice.
Yeah, I don't know where that bar goes, but it's gone forever, I guess. Question. But how can we load a JSON file to the core, download the data, and use it in a file? Yeah, that's a good question. So I've done this plenty of times. So you can actually, in the core itself, are you load a JSON file to the core, download the data, and use it in a file? So I'm assuming you mean you have a specific JSON file you want to load to the core and then pull information out and use it in a
Access.
file. Yeah, if that's the case, then yes, so you can go to the core manager, upload files to the specific core manager, or you can even through scripting, you could save what you download to the core and use it that way as well. So I've used it both ways. When I did the InfoComm booth this year for the operations center, we did that specifically. Every time we had new data, we would build it and then I would save it to the core and then pull it back from there so that it was consistent and stayed through file pushes and those things. So you can actually, there's a files.io command in Lua scripting that you can use to access that information and pull it back. And do all sorts of fun things with it. So
Yeah, I mean, people forget that. I mean, yes, we store audio files there under files, but it could be system drawings, a backup copy of the file. It could be this JSON table, like whatever you want, right? It's a hard drive. So
it
it's
is
really
limited. So you can't. I said it is limited though. There is not. Don't use it as your external hard drive to move stuff around. But
yeah,
yes,
no, I wouldn't do
there is a limitation to how much space is on that drive.
Yeah,
But yeah,
especially the Core 110s, they were down to 1 or 2 gig is all that's left, I think, on those. But
yeah,
yeah, yeah, it's not a portable hard drive.
yeah.
If
But
that's
yeah,
the
it is.
case, I recommend the let's see, what is this one? Panasonic? I don't know. That's a great little high-speed drive. There you go.
Oh, there you go. Nice.
Terabyte.
Yeah, those are very useful. I have that's a terabyte.
Yeah.
I have one in a flash drive that's a terabyte.
Oh, wow. Well, this is Samsung, sorry, not Panasonic. Um,
Oh,
Patrick, our marketing guy, recommended this. He's like, I don't do none of our marketing material is on a computer. He's like, and he pulls out 3 of these and he's like, if
yeah.
this case gets lost, because I was
Yeah.
editing with my computer
Oh,
and it was
that's,
just bogging it down. So,
I
anyways.
can't see it. Oh, yeah, there it is. See, there, I
Oh,
have a 1 gig flash drive or one
wow.
terabyte flash drive, and it's like super fast. I love this flash drive.
Well, while we're just killing time, let's see if
I mean, I guess it is
I may
11.
not. I
Is
may not
anyone
still
else
have
here but you and me? There is a lot of people. Okay.
I have from like 2006. I moved to Nashville and like, was staying in like a temporary corporate apartment and like they had a printer. So I went and bought a 256 meg Sony thumb drive. It was $40,
Oh, nice. Uh-huh.
256 meg.
The Meg. Yeah. Do you still have it?
And I do somewhere, yeah.
Oh,
Literally, I'll have to dig it up, but it's always it just cracks me up. Like, it still works, but
yeah.
I don't know.
Yes, Micah, you will get a copy of the recording. It'll come later this week or next week. So, and Brad, that sounds like a great idea. Dan's gonna have to fund those 1 terabyte flash drives though.
Do what's that?
Brad would like 1 terabyte Q-SYS flash drives.
Well, I do know these ones coming out of if you're going to the Experience Center in Costa Mesa, or
Yeah,
these generic. Yeah, this is Costa Mesa. I think these are 8 gig
eight
at
eight
least.
gig. Yeah,
I know that's not a terabyte, but
yeah. It's a very small portion of a terabyte.
yes. Well, it's 11 o'clock
All right.
Central Time. Thank you, everybody.
Yeah,
We really appreciate it.
thanks.
And have a great rest of your week. We'll see you on the next ones.
Yep.
Oh, I guess
Thanks
I can
everyone.
do a quick little preview on that. We are next week is
Oak,
planning
right?
talking domains.
Oh,
And then I do want to say if you have any interest in our new series of performance loudspeakers, Trip Matthews is going to be leading up a working with PL loudspeakers and Q-SYS designer at the end of the month. We're going to run that for a couple of months too as well. So if you don't get a chance to see that at the end of the month, look for it in August and September as well too. So appreciate it, everybody.